Hello and welcome to this episode of Math with Martinez. We are in my favorite unit, Unit 7, where we are problem solving with trigonometric ratios in our pre-calculus course. So today what we're seeing in this video is working in real world problems using trigonometry to answer real questions that are existing all around us, and how triangles really help us to find values that need to be identified. So let's get started here with defining a couple key terms: angles of elevation and depression. Just what exactly are these? They're the angle that's formed by a horizontal line, which, if you'll please highlight this with me so that we get this straight. The angle formed by a horizontal line, if we're working right here, look at the guy that's at the top of that tower. There's that horizontal line. Oh, I'm so sorry. We're going to do this one. We're doing angle of elevation, defining that. So there's the horizontal line. That's the eyesight line. And then the angle that's formed when you then take that line of sight and look up, and looking up to somewhere above, that is called the angle of elevation. That's this right here. That's the angle of elevation. The angle of elevation is created from the horizontal, from your eye line, and then tilting your head upward. That creates an angle of elevation. Conversely, the angle of depression is created here when we take, that looks terrible, sorry, right here. This is that angle of depression, which is formed by another horizontal line right here, this yellow horizontal line, and a line of sight that's created by looking down from that horizontal. So you've got your angle of elevation, where you take from eyesight and look up, and angle of depression, where you take your eyesight and then tilt your head and look down. Those are the two different angles created. And what's super important is the note that I made over here in the margins. The way the angles are marked with the angle rotation, look carefully at that. The angle of elevation here in this little diagram is an angle that starts down and then goes up. Do you see how the arrow is showing an upward rotation? Whereas the angle of depression, it rotates downward. So angle of elevation starts at eye level and rotates up. Angle of depression starts at eye level, rotates down. Big idea that we need to be aware of. So with that in mind, we are going to work through a few different examples. The first being angles of elevation. So from a spot 75 feet from the base of a building, an engineer uses a transit to determine the angle of elevation to the top of the building, and it measures 67 degrees. If the transit is 5 feet high, find the building height. So first step here is going to need to be to draw out this scenario. So we've got a little person. Here he is, standing on the ground, and there's a building. And he's standing 75 feet from the base of that building. So this distance there is 75 feet. And he uses a transit, which is just a device used to measure something. So it's like a little box thing on a tripod. So he's using this tripod transit in order to measure the angle. So the transit itself is from here to the ground is 5 feet. And we are aware of the fact that the angle of elevation to the top of the building measures 67 degrees. So if it's an angle of elevation, that means it's got to start here at this eye level and rotate upward, like we saw is true for our angles of elevation here above. This is an angle of elevation. So we start at the eye line and then look upwards. And that angle of elevation is an angle that is 67 degrees. And notice what is created with the building. This is a right angle that's been created with our structure. And not only is it a right angle, but then with that line of sight, we create a right angle. And what we're trying to figure out is the height of our building. So we want to know just how tall this whole building is. So how tall is that building? Of course, this diagram is not to scale, so don't judge my picture, and it's lacking in scale because this building is probably, in all actuality, a lot taller than what it looks like here. So let's go ahead and begin. We've got some different pieces of a puzzle that we've got to piece together. Our triangle, if I'm going to highlight it, is here. And it accounts for a portion of the height of my building, which actually I'm going to relabel. I'm going to label this as H. The height of our building is H. And I know that the distance away that my person is from the building is 75 feet. And that actually is the same as what you're seeing for that base of your triangle. But then the height of my triangle is not the entire height of my building. The height of my triangle is just a portion of that height. The other portion is this right here, from here to here, is 5, matching the 5 that was the height of our little transit. So whatever I'm going to do in this problem to actually find height, I'm going to have to take the value and find x and add 5 to it at the end. So keeping that in mind, to find the height of my building, I'm going to have to find x in my right triangle and make sure that I add 5 to it. Otherwise, the building height will be inaccurate. It'll be off. So let's go ahead and look now carefully just at our triangle and think about what we can do with trigonometry to solve for that portion of our triangle. In our figure, the 75 is the side that is adjacent to our angle. And the x, that side over here, is the side that is opposite. So which trig ratio will we use in order to find our value for x? Which one of our trig ratios relates adjacent and opposite? That is tangent. So we're going to take tangent of our angle, and it is the opposite, which is x, over the length of the adjacent side, which is 75. Go ahead and solve for x by multiplying each side by 75. And that gives us the equation 75 times tangent 67 degrees. That's going to help us find x. Using our handy-dandy calculator, we can figure out here that x is approximately, when we round, let's round again to the nearest tenth like we had been doing previously, that's about 176.7 feet. Now that is just x. But what do we need to do to that? We need to add 5 to it because that transit was taking a measurement 5 feet above the ground. And x is only starting at the height of the transit and going up. So the height of the building is actually going to be 176.7 plus 5, which means the height is 181.7 feet. There we go. And ladies and gentlemen, we are going to actually get to do this in a project. So if you're in my class and watching this video, spoiler alert, we're going to get to go do some of this around our building. So stay tuned for that. Let's do another angle of elevation problem. A ramp is being built to access a door that is 1.5 feet above the ground. Find the length of the ramp if the angle of elevation must be 8. Okay, so here's the floor. Here's our door. But the door is some feet off of the ground. So maybe it's in a building, but the door is, higher than that. Actually, let me do it sideways so you can see it better. It's going to be hard to visualize. Okay, so there's the door. The door is right here, and notice it's not flush with the ground. It's a little bit above that. So what we need to do here is make a note that this right here, this height from here to here, that is 1.5. It's a height of 1.5 feet. And then we're trying to figure out the length of our ramp. We don't know how long that ramp is going to be, but that ramp is supposed to come up to the door. And the angle that we have right here, our angle of elevation, is going to be 8 degrees. So that right there is 8 degrees. And what else do we know? Anything else? Nope, that's all we know. Okay, so let's go ahead and begin. We are trying to find this right here. We're trying to find this length of our ramp. We know the angle we're working with is 8. That right there where X is the hypotenuse. And the other side right here, where the right angle is being formed, the top of that ramp, all of that is 1.5. That is the side that is opposite. So which trig ratio is going to relate those? That's going to be our sine function. Sine of 8 is going to be the opposite side, which is 1.5 over our hypotenuse, which is X. All right, so a little bit of work here. This is the same thing as X times sine of 8 degrees equaling 1.5. When we solve for X, that's going to be taking 1.5 and dividing by sine of 8. So with your calculator, we can find that the length of this ramp is going to need to be approximately, what's that going to be, y'all? That's going to need to be 10.8 feet to meet the code required. If that ramp is only allowed to be at an angle of 8 degrees, then that ramp is going to need to be a 10.8 foot ramp to access this door. There you go. That is working with angles of elevation. Now let's think about angles of depression, which we can oftentimes sketch incorrectly. So let's be really careful here and remember that you have to start at the horizontal and then rotate your head down to create that line of sight. The angle of depression is going to be an angle created following that rotation downward. So a wire is attached to the top of a post to a point on the ground 24 feet from the base of the post. Okay, so here's the ground, here's the post, and a wire is attached to it to a point 24 feet from the base. So this distance right here is 24 feet. If the angle of depression from the top of the post to the point where the wire is attached to the ground is 61 degrees, find the length of the wire. Now, remember, for an angle of depression, you've got to start horizontal and then tilt down. So the correct way to sketch this, ladies and gentlemen, is to start at your horizontal, your eyesight, and then rotate down from there. That is the angle of depression. That is 61 degrees. And I know that is actually not the triangle that is created with the post and the wire. So what do we need to do? Well, the two of these angles, if you were to think about this as angle 1 and angle 2, the two of them together create a 90-degree angle. So if 61 degrees is taken up with 1, then how much is left for that angle 2? Grab your handy-dandy calculator and take away 61 from there. That's going to give you an angle of 29 degrees. That's the angle that we're going to want to work with. And we are trying to find the length of our wire. We'll call that, oops, sorry, I deleted some of my wire. We'll call that X. So now let's label our sides like we are in the habit of doing. Labeling the sides, 24 is the side that is opposite, and X is the hypotenuse. So which trig ratio relates those two? That's going to be your sine function again. So sine of 29 degrees equals the opposite side over the hypotenuse. Let's go ahead and solve for X. We'll have to do like we did above and first multiply, then divide by the sine of 29 to get X by itself. And then grabbing your graphing calculator, we're going to take 24 and divide it by sine of 29. And that gives us 49.5 feet. 49.5 feet is the length of that wire. There you go. Last one for this video. One more angle of depression problem. What is the horizontal distance between the point where an airplane begins its descent? Okay, so we've got an airplane. Here's our airplane, its wings, little tail. I know, isn't it great? Such a skilled artist I am. So there's our airplane. What is the horizontal distance between the point where the airplane begins its descent and where it lands? Okay, so sketch up. Okay, the point where it lands. This is what we're trying to find, that distance right there. Oh, no. We're not finding that. We're not saying how long. It's the horizontal distance. So we're talking about, drop a perpendicular right here. We're talking about this distance right here. What is that horizontal distance? If the airplane descends at an angle of 5 degrees from an altitude, so presently it's at an altitude of 7,200 feet. And the angle of descent, guys, from here, from the horizontal down, that is 5 degrees. That is 5 degrees. Now, I actually can think about this two different ways. I can look at that triangle, the one that is like all gray, or I can kind of sketch this triangle, right, from in this like yellow color, thinking about my horizontal line and then kind of visualizing this upside down, because this height here is also the same. And I'm trying to find x, that horizontal distance. This x that I've marked along the ground is actually the same x that you could see up there above that dotted dashed line. I mean, the good news about this is, look, then you've already got the angle, 5 degrees that you're working with. You don't have to do the subtraction and work all that. It works the same exact way. So I just wanted to show you guys that there are kind of two approaches you can take here. So let's go ahead and solve this. The side that I've marked as 7,200 is the side opposite, and x is the adjacent. So when we relate those two, the trig function that we're going to need to use is which one, ladies and gents? That is tangent. So we're working with tangent of 5 degrees is 7,020 over our unknown. We're going to need to multiply each side by x and then divide by tangent of 5. And then we're ready to calculate it. It's a little easier to have these both on the same screen. Okay, so get my fraction, 7,200 over tangent 5 degrees. All right, press enter. Woo, quite a distance. Okay, so let's see what this is. This is going to be 82,296.4 feet. So, wow, okay. Quite a distance is going to be traveled horizontally by this plane if it's descending at just 5 degrees. So there you go. I'm now really curious what that would be in miles, because maybe look that up, figure out what that would be in miles. I'm going to do the same. It's not really relevant to this video. I would have to jump in there. I know it's 5,280 feet in a mile, but yeah, so that, I don't know, that was not what I intended to end the video with, but now I'm super curious. And if you're not curious, that's okay. That's just kind of part of being a mathematician. As you grow in that, you just continue to ask more and more questions. So maybe you don't have questions just about how to do the basic math, but maybe once you start doing this math, it leads you on a tangent, pun intended, that causes you to think more deeply about questions that are posed. Anyways, I digress. I hope that this video was informative and helpful. And if you had any questions, please take a moment to share those now. And until next time, stay fired up.